Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this short recording what we're going to do is we're going to use port B as both input and output. So what's going to happen is we're going to use the top 4 bits, or the top most significant bits, the 4 most significant bits of or B, or port B, as inputs. And we're going to take those 4 inputs and we're going to put them out on the least significant bits of port B, in other words the 4 least significant bits. So it's like the echoing program that we done previously. However, in this case what we're going to do is we're going to take it all on port B. So in order to do this, I'm going to start off by in the user.c. I'm going to set up port B as the top the 4 most significant bits. I'm going to set them up as inputs, and the 4 least significant bits I'm going to set them up as outputs. To do that, I'm going to say tris b is assigned 0x f0. So that sets the top, or the 4 most significant bits as inputs and the 4 least significant bits as outputs. I'm going to write that as a comment as well for MSBs. Okay, so that sets that up for us, and I'll just click save there, and I'll go into main. Now what I'm going to do in main is I'm going to set up a user variable that we're going to store values in temporarily. And I'll call this temp store. I'll set it to 0 for the moment. Okay. Now you'll notice that I've set it as a character. That's not because it's going to hold a letter, it's because it's only going to hold 8 bits. The second thing is that I've used unsigned because I don't want the most significant bit to be treated as a plus or a minus sign, which is what would happen if I didn't. So just to be careful of both of those, I've set it up as an unsigned character called temp store. Now what I'm going to do is I'm going to take in a value from port B. Obviously I'm taking it in from the 4 most significant bits, and I'm going to store it in the value store. So temp store is assigned port B. Okay, so that's going to take in the entirety of port B and put it in temp store, and that also means that it will be reading whatever was previously on the output. Okay, so on the 4 least significant bits it will actually read that in. What I'm going to do is I'm going to do it this way first, and then I'm going to add a little bit of extra safety to it, even though it would work anyway. I'm going to add a little bit of extra safety to it because it's something that I'd like you to keep in mind for future programs that you're going to write. So for the moment we're just going to take it all in, all 8 bits from port B, put it in temp store. Now because it's the top 4 bits of temp store that hold the new input, what I'm going to do, and I want those to go out on the 4 least significant bits, what I'm going to do is I'm going to shift temp store by 4 places. Sorry, I'll write that again. Assign temp store shifted by 4 places. Just in case there are any precedence issues, I'm going to put this in brackets, just in case the assignment might happen first. Now it won't, but it's no harm to just write it that way anyway. Now, so that's what I'm doing. I'm taking the value that's in temp store, which is the top 4 bits is my new input, and I'm shifting those 4 bits down to the 4 least significant bits by using this shift operator. I could do this in one quick go as well, so this would also work. By 1. Okay, so that's putting the operator all in one go, shifting it and assigning it all in one go. Okay, so I could do that, but I'm going to leave the larger version of it there just so that everybody is clear on what I'm doing. Now, what I then do with store, now that I've moved it to the correct position, is I set it to port B again. Like that. Now, just to give you an example of what might happen, so I'll go over here to an example. And we'll imagine that the top 4 bits, well, we won't worry about what they are for the moment. We'll just say they're 0, 0. And we'll imagine that the output is currently 1, 1, 0, 0. Okay. Now, if I change, if my input is all zeros, as it is here, what will occur at this line here is that those 4 zeros, sorry, 2, 3, 4, will be shifted down until they become the 4 least significant bits. And new ones will be brought in here, okay, will be shifted in with this, but they will all be new zeros that will be brought in. So that will then make the whole lot of it all zeros. So this is in temp store. What will then occur on port B is that all of these zeros will be written out. Now, it'll only have an effect on the bottom 4 bits because they're the only bits that are output. So the bottom 4 bits will then become all zeros. Okay, and this will happen for any of the different things that you do. So let's say, for example, that you had all zeros here and you wrote in a 1 on this line here. Okay, so you take all of that in. This would bring you to here, and you would start to do the shift. So you would move that down 4 places. 1, 2, 3, 4. Okay, and these 4 would disappear. So that would now put out the 1, 0 pattern onto port B. So port B would now become okay. So you can see in each case where what's happened is that the top nibble has come in here and has been put out on the bottom nibble, or the bottom lowest least significant bits of port B. Okay, and this will work, but I'm going to make a slight modification to it in a moment just to make it that little bit safer. So let's run this and see it operating. And I only need to look at port B for this particular case. So we look at our I/O pins, and you can see that the 4 most significant bits of OR-B or port B are set to digital inputs. The 4 least significant bits are set to outputs. So if I change this pin here, we notice that the output there has also gone to 1, so it's echoed it out in that direction, and this will continue to work for any of these. And if I change one of them back to a 0, again, its matchup 1 in the least significant bits will also go to a 0. Now, I did say there was one little thing that I wanted to change on this, even though that is working. The reason that's working perfectly is because when I do the shift, I bring in all new zeros, so we don't end up with a mistake. But what I'd like to do is, just in case that there was anything on the output already that would be brought in. So let's say, for example, that that this is my new input that I'm taking in, but on the output previously was the following. Sorry, it was 1, 0, 0, 0. Okay, now that would be brought into temp store and it would be shifted. So I'll just copy it there to show you what would happen. This would be shifted by 4 bits, 1, 2, 3, 4. And in doing so, this problem 1 would disappear off the end, so it's gone. Okay, and so that would write out correctly, and that's why it's working. But the problem is that if you were doing some other programs where that problem 1 was not being shifted completely out and being replaced by all zeros on this side, it could give you a problem later on. So in order to make sure that we don't actually take in this problem 1 or any other values from this, what we can do is we can do the following. We can AND it with 0x f0. And what that will do is it will come along, it'll take whatever the current value on the port B is, and it will AND it with this. Now, when you AND these two together, what occurs is you have in the first column here, you have a 1 ANDed with a 0, and that will give you a 0. In the next one, you have a 1 ANDed with a 1, and that gives you a 1. A 1 ANDed with a 1 gives you 1. A 1 ANDed with a 0 gives you a 0. In the next column, the 1 ANDed with a 0 gives you a 0. 0 ANDed with 0 gives you a 0. 0 ANDed with 0 gives you a 0. And another 0 ANDed with 0 gives you a 0. So that makes sure that it gets rid of any spurious values that may be in here, which could cause you an issues if they weren't fully shifted out of it. As they are in this example, they are fully shifted out of it, but in other situations you may find that that's not enough, that they could become a problem for you later. Okay, so just remember that it's usually best to only take in the values that you're interested in and try and not take in any other values. Okay, so again, we'll just prove that that is still working with the new code. So if I change a value here, we can see that its matching value has changed in the other situation. Okay, so that's working fine again. I'll just change it back to a 0 just to prove that it does go back. Okay, so that's it for this lesson.